Hello everyone, welcome once again to another Power BI related tutorial by Team Slidescope. We are again using the Penguin dataset, but the purpose of this analysis is to understand how to handle missing or irrelevant data. So by doing some exploratory analysis, we will try to understand that, and we will use Power Query Editor. Some features of Power Query Editor like remove rows, keep rows, this type of values, and how to replace irrelevant values, what is the logic that we will apply in different cases. So this will be the purpose of this particular chapter. So let's get started with it. So we are continuing our discussion of Power Query Editor in Power BI, and here we will open Power BI. We will learn about removal operations in Power Query Editor. Removal operation allows you to remove unnecessary rows or columns from your data set, and this is a common data cleaning step to eliminate irrelevant or redundant information. This improves data quality and reduces report complexity. Question is when to remove rows and columns. So we have to remove rows when either we have irrelevant data, that rows don't contribute to your analysis, that is some test data, headers within data can be removed. Next is duplicate records. To avoid overcounting or skewing results, we remove duplicate records also. Sometimes outliers or errors are there, so we have to remove rows that have incorrect or extreme values. For example, I talked about Cbond dataset. So there is a repository on GitHub called Cbond dataset. This is a library in Python, a data analysis library in Python. And there we have a dataset called penguins. So basically this dataset belongs to three different kinds of penguins: Adelie, Gentoo, and Chinstrap. These are the three penguins. So if you see the data, let's say this is the data, just want to give one example. So we can copy the data from here directly, and then we can go to Power BI desktop. In Power BI desktop, you will have option to enter data. In enter data, click on column and paste. So I have simply copied from there, and you can also add it as a CSV file. But the main point is, in this file you will see in some rows we have null values. Okay, so in some cases these null values are just missing gender information, like here gender is missing, here gender is missing. But there are cases where we don't have any data, like we don't have bill length, which is bill length of the penguin, bill depth of the penguin, flipper length of the penguin, body mass of the penguin, nothing is there. So these type of rows are of no use of data analysis, and they are going to change our average, they are going to change everything. So we'll call it penguins, and when you will actually load this data, now you have options to go to edit query. In edit query you will see the data, and now what we can do, for example, we know that in some cases bill length is missing, so we can click here, and in Power Query Editor, in Home tab, you will see the option of sorting. So we can sort ascending or sort descending. So let's say we are doing sort ascending, and we actually see a row that has no data. So we can say remove rows, and we can say remove top rows. How many rows? I will say 1 because in one row I have all the missing values, and when I'll do that, now you can see that one row is gone and now I have no missing values. So this is one way that your data is not meaningful, so you have to remove those rows. Because this is sample data and particularly for exploratory analysis purpose, we must have those kind of data, or we must have that particular data which is meaningful. Next is there still are some blanks in gender column. So if you want to keep those rows, you can keep. Otherwise, you can click here and you can sort them either Z to A or A to Z. And you can see in some cases we don't have valid gender information. So if you think this is an important column for you, and if these missing values are there, so there is no point in analyzing these 4 rows because we still have many other valid rows left. Again, we can now remove rows, remove top rows. I'm just giving a simple trick. Click OK. And now whatever data you are left with is all clean data, like without missing values. And now you have the data. And if you want to create, you can create. Now, for example, if I double click anywhere, so it is preparing Q&A visual for us. Okay. So in Q&A visual, we can ask island wise average bill length. Screen may be too small for you, so I am just zooming it. Island wise average bill length. I am just asking this question. Okay. So it is giving island wise. So we have to write bill length So island wise bill length If I write this, so now there are some cases showing result for island wise bill length and now in some cases you can see it will automatically show this type of data. So now it started showing island wise average bill length and it will decide what type of chart is best for it. Then you can click here, sorry, not here. You can turn this QA result into a standard visual and now it will convert it into a standard chart. We can fit it to entire width, and this is our one way of doing analysis. So this is telling us that in Bisco Island, the penguins that are found, their bill length, average bill length is more. Actually, I have a more detailed analysis for penguins. I'm just explaining use of this Q&A. We'll just try that. So this is one way of removing unnecessary values. Okay, or one purpose why we remove unnecessary values. You can remove columns also, like sometimes in the data set you will get some irrelevant fields or sensitive data, right? There can be some fields that are sensitive data, someone's personal tax identity numbers, social security numbers. So those type of columns can, like, it is better to remove them. To remove a column, it is very easy. Just edit query and whatever column you don't need. Let's say I'm saying we don't need body mass, although we need, so we can right click and remove that. So this is something that you can easily do. So you can remove columns, and here, for example, as we discussed, we can create effects and shadow. This particular data set, penguins data set, is a classic data set of classification where our target field is species, classification of a species. Now there, as you are asking, there are some cases where, see, first of all, I removed all the null values here. Okay, there are some cases where null values might be in between. Okay, let me give you an example. For example, let's say this is day and this is temperature. Okay, this is day 1, day 2, day 3, day 4, day 5 and 6. Let's say on day 1 temperature was 28, day 2 it was 29, day 4 it is 31, 32 and 33. I'm just giving a very basic example here just to understand. This is a missing value. Now, based on simple arithmetic progression or interpolation, linear interpolation, will you be able to guess what number will come here?
No.
Huh?
30.
Think about it. Think about it.
Maybe 30.
30, right? Because 28, 29, 30. Okay. So, you have to understand. Now, let's say this is day 1, day 2. And this is day 6, 3, 4, 5, let's say. And this is day 6, 7, 8. And this is something like 33, 34, 35. So, like there can be this case also where day 1 is given, day 2 is given. So, we will think that on day 3 there will be some temperature, day 4 there will be some temperature. So, it is 28, 29. So, if we consider it is 30 and 31, just giving you example. So, it cannot be directly 33, 32 here, right? Or it can be. So, on day 5 it can be 32. So, you will mention 32 here. Are you getting my point or not? Based on time based guessing, right? Because day number 3 and 4 are not given. So, what you can do? You can even guess day number 3 and 4 also, right? So, when missing data is there, so handling a missing data depends upon many things. Now, there can be cases, let's say it is given like this 1, 2, 3, 4. I'm just giving example. And on 1, let's say I'm just giving sales or let's say any value X. It was 2. Then it became 4. Okay. Then it became 8. So what will be the next value?
10.
Think again. 16, right? So this guessing work, what you are asking me, like what to put there, right? Depends upon that. And sometimes what we do is, let's say this bill length or bill depth is missing, this one, let's say it is missing. Okay. So in such cases, what we do is we take average of whatever is there, okay, and then replace the missing value with average value. You get my point? So we can replace the missing value with average value to keep the overall average same, right? So sometimes we replace with mean value also. So when we write replace, let's say we'll write replace null value with average of, for example, average of bill depth, right? So this, so you can do these kind of things. So in Penguin's dataset, as you can see here, this is bill length and this is bill depth, right, of a penguin. And on the basis of this, three penguins are classified. So this is this dataset. So suppose a bill length or bill depth is missing. So what we can do now, important question. Suppose the bill length that is missing is of Gentoo penguin, right? So that's why we are taking average bill length. So average bill length in Bisco, in Dream and in Torgerson Island are different. Similarly, if we try to find out average bill length by penguin, so we write penguin name or penguin species here. You can see in chin strap the average bill length is different. In Gentoo it is different, right? So overall average will be different. See, I just want to give you a simple example over here. And this is very important stuff over here, handling missing data. So this is a basic penguin data analysis. If we keep a simple card over here, okay, and in that card, the card that we have, if we write average of bill length, we are taking everything as average. This is average of bill depth, and average of bill depth average, let's say in effects we just write a shadow. We're not going to go fancy with this, and this is average bill length. First I will prepare these KPIs and then I will ask you the question. Then this is average body mass. This is sum of body mass and this is average. Okay. Then we have flipper length. Every penguin has a flipper height, flipper width. So this is flipper length average. This is overall average. Okay. Now because species is the important parameter for us, so what we do, we will create a slicer from here, okay, and we will put this slicer as our filter, and we will use this slicer to see if the average is different for different species or not. And from here we will select a simple drop down, and in drop down you know that we can increase slicer header size, we can increase value size. These things can be easily done, and we can select some color like this. For slicer header also we can select something like this, okay, whatever. And here also we can go, I know designing and formatting takes some time, yeah. So if I select the Adelie penguins, so for Adelie penguins you can see that average of bill depth is 17. Let's consider bill depth. For chin strap it is 18, for Gentoo it is 15. So do you think for different penguins these numbers are different? So basically this is the dashboard that we created in our one of our class, penguins classification. I would suggest you guys to go through this. Here in penguins classification you can see we have three types of penguins. One is called chin strap, one is called Adelie, one is Gentoo. Yes, all of them are penguins, but some one of them has more length of bill, some one of them are smaller in size, and chin strap has a smaller bill length but is average in size. So you can see Gentoo, Adelie and chin strap, their bill depth versus bill length are different. You can see. their flipper length versus body mass are different. So everything that you see here is different in them. Now my question is, suppose we have missing data. We have a missing bill length over here. In this missing bill length, will you put overall bill length average, that is 46.94, or will you put bill length average of Adelie penguin, which is 38.77? What will be your call? हाँ,
आप ओवरऑल की बात कर रहे हो, बट सर वहाँ फिल्टर जो लगा है तो इससे 30 पे लगा है, राइट?
yeah, so by default, overall, how many penguins do we have? Overall, we have around 200, 345 penguins. Okay. Their overall average bill length is 46.94, and the missing bill length needs to be guessed, like we are guessing what, or we are filling the not available value, which is called fill NA, filling not available value. So
Can we take the average value?
yes, that's my question to you. Overall average is 46.94. So will you put 46.94 here, or will you put Adelie as a filter, and then you will see that 38.77. Why I am saying this? Let's say bill depth and bill length. Okay, we want to analyze that is the relationship of bill length versus bill depth for these three penguins different. So we will create a scatter plot. Whenever you have to find the relationship, you will create a scatter plot, and in that you will put bill length on x-axis and bill depth on y-axis. Here you can interchange them, and you will say don't summarize, don't summarize. So now, are you able to recognize three different clusters here? Are you able to easily recognize three different clusters here? Yes or no? Give simple answer.
No, sir, no.
No. And if we add species as a legend, now,
Now it's clear.
so when we don't have this information, this is called unsupervised data, right? That you just have x and y, but you don't know how many values are here, how many different values are there. We can say yes, at least two types of values, or three or four, you can guess it anything. But when you have the supervised data, that means you have the information of species. In that case, now you know the range of bill length for Gen2. Do you or no? You know that range of bill length starts from 40.90 and goes up to 59.60, right? And if it is bill depth, it starts from very low value 13.10, at like in Gen 2 it is lowest. That's what I was telling you, that these three penguins, if we actually see that, so someone has a higher bill length, someone has a deeper bill length, or something like that, right? So you can see, and you can see in Adelie penguin the bill length is very low. But we can say that this particular relationship alone is not sufficient enough to answer all the questions, right? Yes, it is important because we can identify three of them. So what we'll do, we'll copy them, okay? And after copying them, let's say we consider two more variables. Let's say we say flipper length on x-axis and body mass on y-axis. You are seeing three of them. This three is on the basis of sum. What if we write average? Average. So you can see now this is also sufficient to answer one question, that average bill length versus average body mass versus average flipper length of Gen2 is very high. Is it or not? That means Gen2 is a big and heavy penguin, right? Gen2 on an average is a big and heavy penguin. On the other hand, chin strap is lightweight and ideally is lightest. So, but here if you will say don't summarize, here you will say don't summarize. So you will be able to see. So now you will be able to understand that yes, we can easily identify Gen2 from this example. Next, what we can do, we can create another copy of it. Okay. So I will increase the chart width, and here instead of flipper length and body mass, I will take, for example, bill length and body mass. So you can take any, like it's like 4 by 4 matrix, right? So you can say don't summarize. Then also you will be able to see that now in this case also we can see that body mass of both Adelie and chin strap is in what range and etc. So when actually you will prepare all these 4 by 4 relationships, the conclusion that you are going to get is that these three penguins have different body masses. These three penguins have different uh, flipper length. Yes, some of them may have, for example, flipper length versus body mass may be similar for two penguins, but other parameter will differ. So even if we are seeing Bisco, Dream and Torgerson wise average of bill length, okay, or we can say Bisco, Dream and Torgerson wise something, for example, in Bisco, in Dream and in Torgerson, how many penguins do we have? So if we just write count of penguins, so you can see that in one particular island, Torgerson, there are only 5 penguins. And I have explained you the usage of ribbon chart. So let's say island is there, and in legend we will put, so island, and we will put the species name, okay, in legend. So you will be able to understand. Then in Bisco only Gentoo is found. In Torgerson only Adelie is found. In Dream both are found. So this will also help you in understanding the data. So this is the way we perform exploratory analysis. So that's why if missing values are there, okay, remember this. If missing values are there and you have to miss or fill this like this temperature example, so go with the logic that if first day is 28, second day is 29 and sixth day is 33, what could come on the fifth day? Guess that. Sometimes you will see options like this, that this is power, right? 2, 4, 3, 16. Sometimes answer will be like this, 3, 9, 27, 81 or something like that. I'm just giving an example. So options can be anything. So these type of methods are known as linear. Linear is simple, like 1, 2, 3, 4, common difference. Then Another one is cubic, quadratic, which we have studied, quadratic, cubic, or then polynomial. In polynomial, power can be anything, like in quadratic the power is 2, cubic power is 3. In polynomial it can be anything, 4, 5, 6, 7, anything. Or it can be logic like this, where you have a missing data. What missing data will you put here? So when missing data is there, and the answer will be whatever is average of a daily, putting that will be a better option, right? And you can do one more thing, that if species is that, and that's why we have these filters, right? So you can create another example that if species is this, because we have two values, so Adeli and Torgerson. So we can do one more thing, and that one more thing will be, here we put island. So that island is Torgerson, species is Adeli. Then what is the average? So whatever is that average, this will be a better answer to put, right? This will be a better answer to guess. Are you getting my point or not? Mon, Shadar. So this is something that we have to do, and let me clear that, and we can get rid of this. And this is a very, very important type of data set for exploratory analysis. Like gender wise, if you want to see what is the distribution of these penguins, so you can put gender as a legend here, and in value anything. For example, yeah, you can say flipper length, you can say count. If you have to guess, because you have to guess this thing also, na? Whether this penguin is female or male. So that will also depend on that logic. So for this, for example, so if we write in values also, we take a species and count of something. So we get information that although by a small margin, but we have more samples of male penguins. But is it the case for all type of species, right? That may or may not be the case for all type of species. So we will select Adelie. In Adelie, male is more. In chin strap, you can see it is 50-50. In Gentoo, it is again male is more. So overall, if we don't have to remove this particular column, and we have to guess what value will come here, so we will select it on the basis of which one has higher percentage. Okay, so this way you will be able to replace values. So this is our chapter that we were discussing, that not this one, that you remove rows or columns on the basis of this logic. If you have outliers or errors also, suppose that overall average is coming as 41, 42, and 4000 was written there. Are you getting my point? So that 4000 would have been irrelevant, na?
Not matching the data set.
Yeah, not matching, so irrelevant as per data. So sometimes those type of values will also be there. For example, this is given and here it is written as something like this. So we will understand that it is because of some kind of data entry mistake or system error or something, right? So or here male female is written, and here let's say Germany is written. I'm just giving you an example, right? So like some by mistake someone entered wrong detail here, right? So If it is irrelevant information, then also you need to check, because this will actually hurt your average, right? Because now the average will be a lot more than what it is if value is irrelevant. Or sometimes it is, let's say it is given as 0. Bill length cannot be 0. It's not always about missing value. It's also about irrelevant value. Or bill length is given as minus 38.9. Can bill length be in negative? Like, will you see a penguin with bill length negative? So we can also, this is also error. So the whole point of discussion is, if you see irrelevant values, so for example, you see null values, you see irrelevant values, you see wrong data types, okay, so you can remove. So you can go to home, remove rows, and you can write remove rows where. So first let's save this. So this is one thing. Now let's say we go to edit query. So in our edit query, so in home we have remove rows. In remove rows, you can see options like remove top rows, remove bottom rows, remove alternate rows, remove duplicates. So you have these kind of options. For example, if we remove duplicates, you will actually, this this will not be valid here, but you can see only one example of each type of species are left. Okay, so this is something that you have to see. In remove rows, if sometimes error will be written here, then you will click on remove errors. Okay, in our case there are no errors, so you can see, you have option like you are not seeing that, but remove rows, remove errors, remove duplicates, and there is an option remove blank rows. So it will automatically remove those rows where any one blank value is there. Okay, this is one thing. Second, suppose we want to replace something, so you can click here and replace values. Okay, so it will find 46.4. Let's say wherever it is 46.4, we will replace it with 46.44. I'm just giving an example. So wherever it is going to replace accordingly. Okay, these type of operations are there. So you can remove rows, remove data, and these type of settings are there. And again, you know that this is data transformation good. Right now I'm not going to apply these things, but we have also studied about creating calculated columns, right? So we can calculate columns on the basis of multiple conditions, right? So that is also something we can do with the help of switch statement, with the help of if statement. We can create, it is thunderstorm, right? So we can create that. Okay, so this is a basic example, and you can try all these options. Remove blank rows, remove irrelevant columns. You can click multiple columns by holding control plus click, and you can remove. Now for example, in this example, that like this was the table, and then your final clean example will look like this. Okay, so this is something that we will do, and you will test it today. And if you have any problems in understanding, so we will discuss that in our next class.